I'm really delighted to be here this morning because this is a very important topic, certainly for us at the National Archives, but of course for everyone in our community. So what I want to talk today about is not so much specific projects, especially ones at the National Archives. I wish everyone had the joy of working with Richard on a project like the one that he's working on, because there's just so many opportunities to come out of that work, but not everybody does. So I want to talk about achieving the promise of AI with modest approaches to machine learning, really incremental, and some of the hidden ways in which we are already working with machine learning, but haven't thought about it that way. So, all right, why are my slides not going forward? There we go. So what problems could machine learning or AI help with? I mean, the first one that is a really serious issue for us is scale. We have over 2 billion born digital electronic records. We have over 13 billion analog textual records and hundreds of millions of photographs and maps. So there's always a need for more metadata to improve discoverability, and that's where automated categorization, summarization, extraction of metadata, whether it's born digital or digitized, is an area of improvement for all large-scale cultural organizations, but really for all cultural heritage organizations. As we see with some of the work that Richard and Cal were both talking about, there are a lot of opportunities and research interest in doing full text data mining and other forms of computational analytics. That expectation is coming back on us as a collection repository, as well as expectations around the introduction of more semantic search functions in our catalog. And as we've seen with a lot of other work in the community, certainly over the last 2 years, AI and machine learning can also help discover past use of biased or other problematic language in descriptions that we would like to identify. But really, machine learning is already in use because there are a lot of types of machine learning, and there are tools that incorporate these forms of machine learning or pattern recognition, another form of machine learning, in our environments already. We have rules engines that rely on pattern recognition. We have natural language understanding, and there's a cat who just moved my slides. Oh, it's always something.
Sorry, I think your cat muted your
It's always something. Natural language understanding, natural language processing, and named entity recognition, of which we've already heard some about this morning. The biggest issue for employing any of these tools, whether they are smaller tools or larger computational efforts, is training. And that I have found to be the highest barrier in finding or developing these sorts of training sets. In some cases, you can train these tools using unsupervised learning, where the systems are fed a corpus of documents or images or sound or video that are not already tagged or categorized in any way to make so those tools can make inferences and then suggest the meaningful clusters and tags based on the content, versus supervised learning, which uses a known training set to teach models to analyze and predict and generate desired output. These are made up of inputs and correct outputs, and it helps the model learn over time. Keeping that cat away. Let me start with a couple of examples of ways in which we're already using it that we might not be thinking about. OCR is a form of machine learning which is based on pattern recognition. I mean, if you think about it, OCR systems are trained using supervised learning with sets of documents or images that uses computer vision to recognize printed text, handwriting, and page layouts to extract information from the digitized text. So examples of this are creating full text for indexing or for data mining by other tools that can understand the named entities or the topical concepts to use in description. Obviously, that word needs a little fixing. Another example that I've seen a lot over the last 2 or 3 years are chatbots and things like Alexa skills. These are driven by rules engines, natural language processing, machine learning. Some of them are declarative, like a lot of chatbots that use predetermined rules and NLP, but very little machine learning because they primarily process the language that they receive, whether it's written or verbal, and generate automatic response. Some of these are more conversational, and they're trained using unsupervised machine learning to create rules like Alexa, Siri, or Cortana that learn from their users. And an example of which certainly libraries are already using this are to handle first-line inquiries from researchers over chat reference. So another form of machine learning that we are already using are regular expressions or regexes, because this is a common programming tool used to find patterns of information in textual or data records. And they're successful because they're trained to use a rules engine that recognizes desired patterns or strings. This is a case where something like unsupervised learning, where you would feed it unstructured text, is a really difficult, non-trivial computing task, and it is rarely used for building regular expression rules. So some of these example projects would be recognizing patterns and identification of patterns, primarily in access reviews for PII, personally identifiable information, so phone numbers, social security numbers, other ID numbers, or to search for already known words or phrases. And there are some tools out there that can already do this that are on the market in use. Spirion Forensics Toolkit, ActiveNav, Bulk Extractor. We happen to use ActiveNav with some of our work at the National Archives. We've already heard a lot this morning about named entity recognition to locate and classify named entities in unstructured text and bring them into predefined categories of personal names, organizational names, locations, time expressions, such as dates. We see this a lot where it is applied on things like the output of OCR. So I've seen a lot of use with scanned historic newspaper collections, where you can identify personal and corporate names, geographic locations, and dates to be used in descriptive metadata. And there are a lot of good tools out there, some of which have been around since the 90s, and some of which are sort of newly being reapplied or restructured into tools for specifically for the cultural heritage world. So the Stanford NER is very well known, SPACY, NLTK, OpenNLP, Gate, EPAD, and RATOM for email, BitCurator, NLP. And there are a lot of implementations of libraries for Python, Java, Node, and other languages. Computer vision. I mean, if you think about this, OCR is one of the most common uses of computer vision, where images are analyzed to identify text. So I've recently, though, seen a lot of growing use with facial recognition for detecting and identifying the presence of human faces in photographs or other digital images, and comparing it to both known and unknown faces to look for a pattern match. So in this way, additional images of known individuals can be identified. Images of unknown individuals can be gathered for identification based on other sources. I know that this is controversial and but I've seen some archives already doing this, and it'll be interesting to see how this plays out in the community, such as only applying it to images in the more distant past rather than anything recent. Some of the technologies are the Tesseract machine learning OCR, OpenCV, Face++, and Amazon's AWS form of recognition, which seems to be winning out in that space. Speech to text. If you think about that, speech recognition, where we're doing automated transcription of audio or video. It's really using a form of natural language understanding and natural language processing to take what the inputs and translate those into text. So these speech recognition tools can be either speaker dependent, trained by an individual using test sentences like if you were using something like Dragon, or speaker independent with no speaker training, which is the sort of thing we would be much more likely to use in a cultural heritage organization. So think of this as something that you apply to archival audio and video to create transcriptions. With it, you can then either supply for full text indexing or mining, or then run it through other tools to do named entity or topical concept extraction to use in description. And there are a number of these tools out there: Caldi, Julius, Project Deep Space, Amazon, Google, and Microsoft, of course, all have their own tools. The Microsoft tool, the Azure Media Services Indexer, used to be something called Mavis. So this incremental approach, there are really several commercial and open source tools and libraries which support rules engine and pattern matching through regular expressions, which can be customized for local use. And there are an increasing number of named entity recognition and extraction tools and libraries that can be trained with these marked up documents or unmarked up documents and vocabulary lists. I mean, the real message here with this sort of quick overview of incrementalism is that you really should not be worrying about finding the one and only perfect big AI tool that will produce perfect results. You should really be looking for a suite of smaller individual tools that meet focused needs, such as the processing of email or facial recognition or named entity extraction from OCR'd texts, and understand that none of these tools are ever going to produce perfect results. The goal really is to take these individual tools for focus needs and bring them together into some automated or semi-automated workflow that solves your focused need now, be it an individual collection or type of collection. Because if you get too invested in perfection, you're never going to make progress. Imperfect results are better than no results when the real goal is helping researchers discover and use our collections. So thank you.